What's up, Algebra 1 students? This is Lesson 18, and our objective for today is what are like terms and how do you combine them? So before we start talking about like terms, we need to talk about what is a term. If you don't remember, let's just do a quick reference. Remember, terms are separated with plus or minus signs. So down here, this is a term, there's a plus sign, so that means this is a different term. It's a different term, it's a different term, it's a different term, this is a different term. So this one would actually have 1, 2, 3, 4, 5, 6 terms. So this is 6 terms. Okay, now when we talk about like terms, these are terms that have the same variables raised to the same power. So, for instance here, this 5x and this 2x are what we call like terms. I'm just going to just circle both of those. That one and that one are like terms because their variables match exactly. They both have x's. But they're both x to the first power, they're not x squared or something like that. So this one here has an x in it, but this is an x squared, so therefore it's not like these others. This one's not like the others. Okay. Switching colors, notice here we have this 6y and this 3y are also like terms. They're also like terms because again, they both have just the simple y in there. They don't have y squareds or y cubes or anything, so these two are alike, so I can combine those two together. This one doesn't have any others like it because it has an x and a y, and there's no other terms that have an x and a y. And this one doesn't have any others because it has an x squared, and there's no other terms that have an x squared in it. So to combine these like terms, like to combine my red ones or to combine my blue ones here, you just add their coefficients, so these numbers in front. So if I want to combine my two red ones, I'd say 5 plus a negative 2, or 5 minus 2. So I'd have 3 x's. If I want to combine my blue ones, sorry, it was a poor choice of colors. So my red ones would be 3 x's. If I add my blue ones together, 6y's plus 3 more y's would be plus 9y's. And then those other ones don't have anything like them, so this would just be minus 3xy plus 3x squared. So that's what it would look like to combine that, or to simplify that one, combining their like terms. Which is the instructions here that we need to do for these ones in example 1, combine like terms. So notice here, 4y and 9y are alike because both of them just have a y in there, so I'm going to add them together. So this is saying I have 4 yaks and I have 9 more yaks. How many yaks do I have altogether? Well, I'm going to have 13 yaks altogether. Okay, so just don't get confused about maybe trying to do something strange with exponents on them. You're just adding, I have 4 of them, I have 9 more of them, how many do I have now? This part B is going to take just a little bit of simplifying maybe first, but we can do that, no problem. This is the same thing as saying negative 3n minus a minus 10n would be like saying plus 10n, and then I'm saying plus 8 more n's. So notice actually all 3 of these terms, 1, 2, 3, are alike because they all just have a simple n in them. So we can combine those together. So if I add negative 3 plus 10 plus 8, I'm just going to add these two first. 10 plus 8 is 18. Then I subtract 3, would give me 15. So this is going to be 15n. Is that simplified down? One more here. This one has 3 terms. 1, 2, 3 terms. Notice this one has an xy, this one has an a, and this one has an xy, or a yx. But if you've read this, remember that a times b is the same thing as b times a. Kind of an example of that, 2 times 3 is 6, and 3 times 2 is 6, and 2 times 3 is 6. So those are going to be the same idea. So even though this one says yx, it's still the same thing because both their exponents are just simply 1, and there's no additional ones, right? If this was x, y, z, then that wouldn't match with that one. But since these just both simply have an xy and xy, then these two, this one and this one, are like terms. So 12xy plus 2xy would be 14xy. And normally we go with the one that's more alphabetical, but either order would be fine there. What I meant is you could have said 14yx and it would have meant the same thing. And then of course I have that one more term that I didn't use or combine with anything, so I'm going to have to just write it down here, 4a, negative 4a. So this would be my answer for that one. Alright, let's do a few more. Same idea here, just combining. So let's look at this one. There's 4 terms, an x cubed, a z squared, an x cubed, and a z squared. So I realize that this is an x cubed and an x cubed. Those ones are alike. And I see this z squared and z squared. Those ones are alike. Now it's not written in front, but there is an invisible 1 in front of these, right? Because 1 times x cubed is still the same thing as just x cubed. So we tend to not write them. Why write something you don't have to? But there is a 1 there, just as we're trying to add these, it's easier to think about. So here, I have 1x cubed plus 1 more x cubed is going to give me 2x cubes plus I have 1z squared plus 1 more z squared is going to give me 2z squareds. And I cannot combine the x cubes with the z squareds. So that's going to be my answer right there. Alright, this next one is 5n cubed, 2n squared plus 4nx squared plus nx squared. So let's see if we can find any that we can combine together. I'm looking, these first two, I almost wanted to say you can combine, but notice this is an n cubed, and this is an n squared. So I cannot combine those two together because their exponents don't match. If this was an n squared or if that was an n cubed, then I could, but since they're different, I cannot combine them together. So I will just write them down here. 5n cubed plus 2n squared. But I do notice, however, that this is an nx squared and this is an nx squared, so those two do match up. So 4 of them plus 1 more would give me 5nx squareds. And that would be my answer for that one. Alright, here's another one. Let's see what we can find out. This has an xy, and this one has an xy. So those two I can combine together. 2xy and 3xy. This one has an x squared z. That one has an x squared z, so those match exactly, so I can combine those together. X squared z, x squared z's. So combining the blue ones, I have 2xy's plus 3 more xy's is going to give me 5xy's. It's going to be a minus 4 x squared z's minus 5x squared z's is going to give me a negative x squared z. And that's what my answer is going to come out to be right there. Because on that one it's 4 minus 5, which gives you that negative 1. But I don't have to write the 1 there, so I'm not going to do that. Alright. Example 3 says the Olympics use a standard-sized pool for swimming competitions. Find the perimeter of an Olympic-sized swimming pool if L is equal to 10x and W is equal to 5x, and then x is equal to 5 meters. So remember up here, this is the perimeter of the pool. So let's just see if we can plug that in. The perimeter is equal to 2L plus 2W. Well, L has another name, so my perimeter is going to be 2 times 10x plus 2 times W has a a different name, 5x. So simplifying that down, this is going to give me 20x plus 10x. Notice those do match exactly because they both just have a single x in them. So that means this is going to come out to be 30x. So that's my perimeter. But they also give me this additional piece of information that x is equal to 5 meters. I'm going to come up here where I have more room. So it means the perimeter is going to equal to 30 times 5, because again that x is just simply 5. So it's going to be 150 meters. So the perimeter of an Olympic-sized pool would be 150 meters. Okay? If you haven't seen your homework already, it starts on page 100. You're going to do all of them from lesson 18, all of them from lesson 17, and 6 more of your choice for a total of 20 homework problems. Good luck!